So hi, welcome everyone to the seventh session of the OpenMusic Study Group. So for this, I thought looking sort of into a deep dive into OpenMusic would be useful. It's just Just and I here today, so we're both gonna show the different things that we've come up with about loops. So yeah. Do you want to go first, or do you want me to show what I've done?
Start it up, and then I'll probably get ideas of stuff that I've done.
Sure. So, I mean, I tried to do as much as I could, trying to think about what a sort of what OM loop can do. The thing that I came up with was just to kind of go through. I mean, OM loop I find pretty good, but it's for a lot of times I'll kind of build my own sort of list loops because there's a little bit more control you can have with it. For this, the on list. I don't know. Have you used much of that?
Yeah.
So really, it just kind of iterates through a list by each element, and you can sort of see this one will work with numbers, symbols, floats, and even strings. So it's quite a good. There's some of these will work with all the data types, and then some will just be really it's down to sort of these at the top of the loop, whether they can sort of use the just working with numbers, or whether they'll be able to organize the sort of symbols and strings. But that's here we can see the collect obviously just collects them all. The count loop I thought was quite interesting.
This one I haven't used before, the count loop.
It's pretty good. It'll just count up the elements in a list. So here you can see I've used a little print function to try and sort of show what's happening, because I think especially when I started, I just you just kind of learn, well, this one goes into each time, this one goes into finally, and you don't really know what happens in between, or what really is going on. So here's our list loop, and you can see I mean, if we go into the documentation, we can sort of see the counter will count during the iterations of the loop. So this is list loop. So obviously, if the list has 4 objects, this is going to loop around 4 times. And in this, we can sort of see. I mean, I always find these quite interesting. They're never really that helpful in telling you what they do.
But you get a rough idea. Really.
You get a rough idea. So here we go. If we obviously print our if count is going to look at this, the first element is going to go 1, 2, 3, and then 4, and then this is obviously what the finally is going to then be what's going to pop out at the end once it's finished running. Summation, kind of obviously this is something that will only work with numbers, because you can see it's just adding. So we've got 1, 2, 3, 4. So we're starting our list loop, and we're kind of going through and adding to the last number until we get to the end of it each time, and then finally it will spit out. So you can see if you try and connect it to something that's not, it's gonna just not know how to add A and B together. Because I know in in other programming languages, if you add strings together, or it'll just concatenate them, but Lisp doesn't.
I suppose you would need a kind of you would need to do this with accumulation, with accumulation objects.
I mean, it's in Lisp, if we take it's let's see if I can do this from memory. Concatenate. Let's see how that works. So it's a concatenate function, just which you then tell it what to concatenate. Let's see if this works.
It looks logical up until now.
It concatenates them. There you go. So you can. So I know in.
So normally, if you would put this in a loop with an accumulation object, it should be able to, like, you would have a list. Let's say you have a list. Let's take this ABCD. That you might need to add. I don't know if you need to add parentheses, quotes.
Yeah. So here's our accumulate. So so it'll take 16, and then if we pass it a string.
So let's try.
Doesn't want to work.
Foobar hello world.
Yeah. So see, I'm not sure. I think this is one of these things.
Let me try. I think I know.
Yeah.
Yeah.
Have you got your screen up? Do you wanna?
No, but I'll see whether it does what I think it should do, and then maybe I can show how because I use this way to make a concatenation for chord sec objects.
Okay, so
to have a list of chord secs and automatically concatenate them rather than having concat in a kind of waterfall.
Oh, of course, yeah. So what did you do
then? Let's go with the foobar hello world. So from the list loop, the first value, which I think you have as number 10 in the original, you should take the Lisp first object, I think, like from the list, or I think directly from your input.
So does it have to be list, or could it be car?
Car.
I like the car.
Maybe
just take the first. Let's look. So I think does first return it as a list, or does it just return it? So it just returns the car, which is funny.
I didn't know.
There you go. So there you go. Well, that's it. Lisp. There's 10 different ways of doing the same thing.
Yeah.
So
but as I understand now, it returns it as an atom, I suppose. Okay.
So this will.
And then you need to. I think you need to now make this little concatenation function.
This one?
The one you wrote, I think.
Oh, using this, so we get. I still have it in my. Oh, I have it right here.
You could copy paste it.
Does it just need? Yeah.
I think so. And then.
Where do you want me to put this? The concatenate.
Where you put the plus lambda.
So just take this. And it probably needs to be in lambda function as well then.
Yeah, sure. And then from the Lisp loop, I think you need to cut out the first. So you need to take the rest.
Yes.
Because you have already entered the first element as the initial value of your list. So the rest of the list loop should be everything but the first element.
Right. So we need to take
that's CDR, I think, or
yeah, that's the rest of the list.
Yeah, exactly.
So,
and I think they should. I'm not sure if it's going to work because I
let's-
know there was something which each time.
no, that worked. That worked.
Yeah, voila.
Well, we've taken everything and added it in. So these
But
are
maybe
all one
put a
string.
print object one time on each
That's
time.
very true. Let's have a look.
See what happens exactly.
Yeah.
Because it should, in theory, it should go foo bar, hello world.
Yeah. So we've got foo bar. Jump straight in. Foo bar hello world.
Yeah.
It's because we start with
foo as an initial value. Yeah.
Great.
And so like this, you could actually, for example, also do like, but this is something I wanna approach in a few minutes when you have finished the first just exposition of the loop. You could, in theory, for example, say like, give me first so many values, for example, of a partial series. But then, especially with this accumulation object, it's very important to give it a stop function.
Yeah.
To see that it doesn't go in an infinite loop.
Yes. But that's
and that is something which I often struggle in controlling.
Yeah. Well, this is what your while loop is quite good for that. So this will do something until a criteria is met. So here we see.
That's interesting. I never use. Wow, that's very.
So this is our list loop that is just going to collect stuff and put out the list. So we've given this a condition. So it's going to take a Boolean. So obviously, I can't evaluate this within a list. But so here we see the moment to, well, it's going to be.
Yeah, it's giving this t or nil.
If I put here, so 0 is going to be less than 1. So we're going to get our 2, 3, nil.
Get a false nil.
So if we look at our while loop, we're listing these things until it gets to number 2. If I go for 3, it's going to just hit until it hits the number 3, and then this is going to cause it to exit the loop. Because this is a list loop, it'll always just, whenever the list is ended, it will just stop. So even if I give it 5, it still doesn't go to an infinite loop because it can only list through how many things until finally. But obviously, this gives us a kind of way out. So
that's interesting. I didn't this while loop thing. I never used, but it works.
So it's a way of getting out of, if you've got a string, or if you've got something that's gonna loop forever, and you can use
exactly
while. And then there's a couple of other ways as well in the I've kind of gone through some of these. Do you want to, well, before I dip into this, have you got some other of the OM loop stuff?
Yeah, I can show you my
yeah, because it might be good to show for you to show us that first before we delve into.
Let me see. I'll start sharing. You need to enable the screen.
I thought I got that right. Oh, I should always have a look and make sure I've done that. And I can never find it at the
magic button. In the meantime, I'm gonna search for.
I think. Yeah, there we go. That's that done.
Yeah. Well, it's actually an application of of this idea of, let me see where I can find this. Range filter. I'm not sure anymore where I put them, but in any way, yeah. For example, this would be this kind of. Actually, I might just take this and quickly generate a new patch to show the problem.
Mm-hmm.
I'm just going to copy paste quickly this. Make quick new patch. Let's go for the scratch pad. Come on.
Down at the bottom there.
I need to make it bigger. Yeah. So let's say that I have generated this sequence of, it is actually, it are odd position partials. Mm-hmm. So I've given, like, I want number 0, number 1, 3, 4, 7, and so on. Yeah. And say that, for example, I want to build the same sequence now on each one of those nodes. Mm-hmm. So first, I wrote actually a little function. I think it's like this now, to compress the original within a certain region. So if I do 1200, I'm not sure, it's a long time ago that I used it. So I think, let me take this out, instantly plug it here, like this, and then reconnect underneath. You have the same nodes, but compressed within, I think, an octave. Mm-hmm. Yeah. And now I'm going to take the same function and in a loop. And for example, I would like to apply it 5 times or 4 times, or apply it until I reach, let's say, maybe all 12 nodes. Yeah. All 12 chromatic nodes. And especially that last one is something where I struggled a little bit, maybe to, so like to make a loop run, for example, until a certain condition is met. Yeah. And I didn't really figure out how to do it. So let's construct a loop, and let's start from the idea that I want to make it run now on the A. Mm-hmm. Until, so I take the second of this list, which gives me the node A. And then I pipe it here into, so construct until all chromatic nodes are present. So if I just apply the original function on this one in a first degree, I get those nodes. Mm-hmm. And I want to loop it until the loop, inside the loop, there is an algorithm that says, okay, now I have all the 12 nodes present. And say that to be sure, I put in here, round, or what is it, MIDI to, what is the score function to approximate MIDI, sorry, yes. And now I should have, yeah, so now I have nice chromatic.
Yeah. So you wanted to just loop through
in theory so many times until at each time there is a condition met that stops the loop from running because it sees that all 12 nodes are present. So I think at least that requires an arithmetic series which just goes.
Well, if you're the odd pgen only produces 12 pitches, doesn't it?
No, it produces 1, 2, 3, 4, 5, 6, 7 new pitches on the basic pitch. It's just a partial generator that picks out the odd harmonics.
Okay. And you want to generate one from, yeah.
And so I want to try to, this is actually a pretty practical situation, which I would run into in real composing work. Like, I want to generate this list. So now, let's say it generates now a new sequence from the A, and this A contains 8 nodes. And then it would need to continue.
Yes. So so you've got, sorry, let me jump on my little tablet here. Oh, can I not annotate on your screen? I'm sure I can.
Maybe.
Where's the, because I wanted to, I thought there was a,
so it's just generating.
There we go. So so we have our 7 notes here, and you want to generate, so this one, you'll get your 12 notes, then it will move on to the next one.
Yeah.
Give 12 notes, and then
give 8 notes. Huh?
And so forth.
So forth until, and collect them together, and then compare them in each time to see whether the condition is met that all chromatic notes are present.
Right. Well, let's
maybe
take it step by step.
A little bit too complex
let's think about it. So our let's look at our basic sort of input here is going to be a list of 7 notes.
7 pitches. Yeah.
So 7 pitches. So I'm just going to write ... And our output is going to then be a list of lists of 12 pitches. So, and there's going to be 600, and then we have our 12, and then we'll go into the next one.
Yeah.
And our 12, and so forth. And there'll be 7 of these. So
in theory, normally, because it's always on a different note, after a while, you would have all chromatic tones. I think.
Yeah. So I think certainly first thing would be the list loop is gonna, or it's gonna break these up into the individual lists. So if we have a list loop, and then a patch with the algorithm SIR 12.
Yep.
So that the output of the list comes into that, and that will give us our 12 pitches, and then you're just I think it's just collect then.
Mm-hmm. But it's in this yeah, up until there it's a pretty conventional loop.
Yeah.
But then comes the point of comparing the intermediate results, which I personally find a very interesting possible element of the OM loop, that you can how to say, you can put a generative process into action, and you leave it be until a certain condition is met, because that's
right
how, for example, generation in nature also works, or in generation in musical IDs, you improvise or you do something until a certain condition is met, and then you say, okay, this is here, it can stop. So because a lot of loop examples always start from fixed amounts, because obviously that's the easiest to implement.
Yeah.
But it is this conditional thinking which I think is much more artistic, or much more useful in a musical context. So anyway, so I think let's construct let's just do it the stupid way. I just construct a list loop. I make it engender the new series. Is this correct, CDR? I often use this one, the one built in OpenMusic. I don't know why they are different, but anyway, it doesn't matter so much. Gen one time. Collect it here and then hook it up. And so now, and I'll also put in, a print to have the intermediate results. And this should, I think,
so I think it's your list.
Let's do this. Come on. Do we need to put it like this? That's another thing that it's hard to debug.
I think it's because you're oh no, it's not. So your list loop is going to print out a single. It's not going to be a list. So you're open up your loop and see where it says CDR.
Yeah, here.
That out and put list.
List
or flat.
Yes, I see.
Whatever, just to give it.
And then re-put.
And then that
CDR.
will.
It's true.
No, you don't even need your C. That will be the first pitch. So you could connect that flat to the ODDP gen.
Oh yeah, okay, yeah, it's true. Yeah, I was thinking like I already have it, but it
list.
Needs to. Yeah, it's true. You're right.
So that should work.
or it doesn't. Generic function flat. Okay.
Type maybe take out the. Let me see if I can. It's
maybe
so
I
hard
need to
look
put the flat first.
No, it should be
Flatten the list here.
because your list is. So I'm gonna open it up, open up a little patch and see if I can.
Ah, now it works actually. I just.
Oh, so the flat needed to come into the top.
Apparently.
Oh.
Yeah.
Well,
so now I have this huge amount of.
Yeah. So.
And then there should be at least here, I think. Sorry, also this one round approximate MIDI.
Yeah.
Okay, and normally we would have okay. So now if nice.
So because we're printing out the individual lists and then we're collecting them all.
Yes.
Yeah.
So this is
the list of lists.
odd partial constructor on every node of the original list.
So what's the condition you want?
Now, so theoretically, in this list already at this point, you have all chromatic pitches.
Yeah.
And so say that so here I would condition that each time the new element comes in, it compares to arithmetic series, or to at least it compares whether all chromatic pitches are present.
So, but it's gonna, so this each time is going to be for a single note.
Yeah. So do you think so?
Yeah.
Okay.
Because that's their output. So use so these the sort of the arrow, the OM with the greater than symbol is this. So this is what's being passed to it each time. So you can see that it's each time.
Always a single
it's
list.
Always going to be, it's going to be the list
that
gets passed each time, and then finally all those lists are combined together and are collected and put out.
So what about putting a second collect object here? No.
But you've already got your collect object here. What you might want to do is put this loop within a loop.
Yeah.
That will have our while condition.
Yeah. Okay. Let's try.
But I don't know if it'll necessarily, because we're working from a list. It's always gonna just stop when it gets to the end of the list. So if you're looking,
at least one thing that surely needs to happen is that this final, let's say this final list somehow gets translated to abstract pitches. So I think for that to happen, or because otherwise it will take a C in a different octave as a different note.
Yeah.
So let's, I will already put inside this node to MIDI send to node. So
yeah, you're wanting,
and then normally if I reevaluate, that's interesting. Can you do it like this, that it cuts the octave number? Or do I need a pitch class something. Maybe I need a pitch class.
You could do both because that's retrieving a string. So you could literally loop through that and remove.
How would you do? Actually, that's
element.
interesting.
But I don't know whether that's going to do what you want it to do. I think the best thing would be to turn the pitches into sets, so that
Yeah, you have the
into
one,
like a modulo
0 to 11,
exactly.
the 0 to 0 to 11.
Yes, modulo 12.
Yeah, then
and then that will
work, I think. Let's try it. I think it's here now.
Yeah, om dash dash or slash slash.
Yeah.
I think you might need to divide it by 100 first.
Let's see. Yeah, maybe. Let's put this on the side. It's an interesting case study because this idea of generating until a certain condition is something which I often use in composing. But now, why do I have two?
You just got one's going to be the remainder.
Okay.
So I think it's the first outlet.
Yeah.
You just need to connect up.
Let's see. Evaluate. Oh, that's.
Oh, you didn't divide it by 100.
Yeah, I just put by 1. Sorry. Let's type it here to be clear. Let's reevaluate.
There we go.
Yeah.
So,
see, now you can actually see pretty clearly.
So you wanted to remove.
So, for example, here.
Yeah.
We have 1 to 11.
Yes.
So let's say I want, for example, I want to loop it until, let's say until 10 is met, for example, until everything is inside here, you have the first 10.
I don't understand what it is you're.
So I want to, or you wouldn't do that with a loop, maybe.
I think you're.
So it generates first list. It's generated. It checks, do I have a 10?
Yeah.
No. If I have a 10, then I go. I regenerate a new list. Do I have a 10? No, I don't have a 10.
Right. It's not. I don't think a single loop is the thing to do with that. This is recursion.
Recursive. Exactly.
Yeah. So
that's my really big black beak.
Right. Yeah.
In OpenMusic.
I do definitely. So any recursive stuff I've always done as Lisp code. OMLoop is not
the right thing.
Not the right thing. You're really wanting a you're gonna want to write this in Lisp.
Okay, that's totally fine. Then maybe we add this for a next next session, because recursiveness is something also in Bach. It's very strongly implemented, but I always struggle in using it. And I don't know if it's my improvisation brain, but recursiveness is an extremely important element in my composition practice. in the way I build the structures. And so I would really love to control it, to master it more. I will maybe then quickly just show this concatenation that I was talking, this concat function.
Yes, I see.
So, but it's actually just the same as.
Yeah, but you wrote out the you used their own concatenate.
Yeah.
Which is
so
pretty much the same thing that I wrote.
It can concatenate every type of musical sequence.
Yeah. Whereas mine was working with with strings. So if you can, I think it's in the hyperspec, you can actually look at what the different arguments that you can pass to concatenate.
Yeah.
And then you could use that accumulate to be able to build anything. I think even the symbols then as well.
Yeah. So up until now, when I wrote functions, also like this oddpgen, I think it should be here somewhere. On methods, where did I put this? I usually it doesn't seem to be here anymore. I usually just write a patch and then I make a generic function and I just paste the post patch in. But okay, yeah. Anyway, yeah. So,
no, I think
but I always read in the manual of OpenMusic that you should be able to use OMLoop, and especially this accumulation function is present for is implemented for recursive purposes.
But they're probably I mean, for me, there's a really good chapter in Practical Common Lisp on recursion.
Okay.
You can find it online.
It's the one by Heinrich Taube?
I can't quite remember. Recursion.
This one,
I think it's I think it's Practical Common Lisp has the chapter on it.
I don't see because I just took the book in front.
He uses the story of a sorcerer's apprentice and a dragon, and it's kind of got the dragon will perform recursion.
Recursion.
The dragon will provide him with mathematics, or like it will give him and it will answer an equation, but it'll only answer the equation once. So he always has to ask the dragon questions in a way recursively, so that he's only asking one question, but the question itself is constantly being asked upon itself.
Yeah, exactly.
And it is like, I mean, it's a silly, or is it a gentle introduction?
Yeah.
I think it might be a gentle introduction.
I think that's the one by Heinrich Taube.
Let me see. Recursion. Yes, chapter 8. Martin and the Dragon. So it's that one, a gentle introduction. And it's got in chapter 8
I've never gone through this whole book, but I maybe should.
Chapter 8 is very easy to read. It's actually I haven't gone through the whole book. I think I just picked out chapters.
Some stuff,
and it's really, it's not it's not like a heavy read. It's
So,
actually quite
yeah,
manageable.
what I've seen of it was always.
I think it's page 244. If that helps, you can.
Yeah. Oh, wait, come on. Okay.
So you should be. It's.
I haven't hooked up my computer to the keyboard. 200. That's. Oh no, I'm way too far.
Oh, 232 in page numbers.
Okay. Yeah, almost. Oh, wait,
So you're in chapter 8. So now you see the. So that's the
recursion
there.
Okay.
So this is it's quite good. It outlines a few things about recursion, and you'll need these while statements and things to get yourself out of infinite loop, because recursion is you can very easily get into infinite.
Yeah, exactly. And wait, what was it?
I've always just found it easier when doing recursive stuff, to just type in the Lisp code, but maybe that's me being lazy. I'm sure listloops is probably possible.
I suppose so. I mean, yeah, see, so this is one, see here, down the page, this was this kind of recursive, and this is stuff that I use a lot, and every accumulation loop that I build, it's a pain in the ass, because it gives errors or whatever problems, or it doesn't accumulate in the recursive way that I want it to do. So it's something which I have the feeling that if I want to really use it the way I want to use it musically, I should study this a little bit more. Anyway.
Okay, sorry, I'm looking up the. There's a, in the chapter they give you the Lisp code for recursive statements. So I'm gonna see if it'll work. Just put in into the lambda. So let's see. Recruiter. Oh, it'll not work because I have to call it self. So I could do it in the Lisp listener. So you can sort of see this. You can sort of see the recursive function here. There's the function, and then you're literally calling the function within the function.
Yeah, exactly.
So now.
And where do you get this information? The page that you just showed?
That's literally the page that from that chapter.
From that book. Okay, yeah.
This is
I see.
This is the first dragons
question. Yeah, the nice story.
So he asked the dragon
but that's really cool.
It works down the list, so we could put in our anyodd, and it tells us yes, there are
odd
numbers. Well, if I go to 4, 6, it'll tell me there are no odd numbers.
Yep.
So it's so it just returns a boolean of whether there is or is not any odd numbers within the list. So that's
But exactly this function calling within the function itself, what I should develop more.
That chapter is very, very easy to read. It more or less gives you exactly what you need to start.
Because
the syntax makes a lot more sense, I think, in the Lisp code, because this is what I'm not sure how you would do this within loops, because you would need to be passing a loop back into itself, which I don't think is possible. I don't know.
It should be possible, as far as I've read but the thing is that they link it in the manual. They link it constantly with this global, with the idea of a recursive patch, which you put in your workspace, and then you call, and it doesn't make things clearer.
I haven't bothered with it in that sense. Maybe I should. I'll have a look at that as well. That might be an interesting thing of getting recursion, but certainly I find this much easier. to just say, hey, here's the function, and then here it is again.
It's a very interesting new way of looking at it by just writing it exactly as Lisp. I think I told you before, the using bare Lisp code in OpenMusic is still something where I'm pretty new to, but the more examples that you show, the more I think that it's actually often easier to do it like that than to do it in the OpenMusic dialect, so to say.
Yeah, I mean, it's got its advantage. I mean, they're so well integrated, you know, it's you can bounce between, like, you can see how easy it is to kind of bounce from one to the other and put them inside each other. I mean, even here, I'm going to show a lot of the looping functions here are fairly standard stuff in here. Like here, there's our for loop. I'll quickly go through some of these. Like some of these are going to just give us the same output very often from, you know, here it takes these extra arguments that we can just kind of fire in quite easily. So, you know, here's a loop that's just going to like not take for any, just going to add up the numbers below 5.
So wait, let's
so here
first, so it doesn't require an input.
Nope.
It's just counting itself from just 1 to 5 and summing until it's lower than 5.
Yeah. So here we can see this is me pretty much like we did putting the print function each time. So so if I add that in, you can see what we're doing. 0, 1, 2, 3, 4, and it adds them all up. Here, you know, we can from to, so we can, you know, take our numbers from 5 to 10. This is going to be like our Lisp or our list. You know, we're introducing a list in, so it's for in a list, and then it's going to add up those numbers. So that's pretty much the same as the sum. You know, if we look at, these should be the exact same numbers. You know, below 5, obviously counts up until that number. This is like this is pretty much the same as the when or while function. So this is go while, you know, this is going to receive this is going to do it until something is met. So this is going to introduce when. So when this is an odd number, it'll add it. So it'll take. So it's looking through the list, finding the odd numbers, and
and E is always the index, probably.
Sorry.
The letter E is actually probably short for index.
Yeah. It's going to be it could be X, or most convention is I or J. in loops. So yeah, these are, you can see summation. A lot of the things that we have here exist in
pure Lisp.
In pure Lisp, and then here we can have when this is equal to this, just pop out. So here you can see it's running through the list, doesn't get to 10 because this condition is met, and it immediately jumps to the next line. So we get 8, and then it goes, you told me to return foo, so I'm going to return foo. And you can see it's very, you can kind of string these together quite easily. Here we go. Here's another. We're going to collect and add them together. So this is going to add the previous.
And there now, how does it know? Wait, for e in x collects e plus e.
So our list is coming in. So I sometimes use x for bringing stuff in, and then this is our list loop nearly, and then it's going to collect and then.
And how does it now here to know to stop? How to stop?
Because it will only go for the length of the loop.
Ah, okay, yeah.
Because we're in. So as long as there's something coming in, it'll be able to run. But as soon as it gets to the nil.
It's the equivalent of listloop, kind of.
Pretty much.
Yeah.
We can. I think sometimes, these will. Very in a similar way that these will only work with numbers if they're given a sum or whatever. But obviously there's in this one we can actually we can use by, and this is almost like stepping through the list, so we can sort of see if I connect the numbers. We get our 0. This is going to return nothing because I'm not going to ask it to return something, but it's going to step through the list.
Yep.
If I change this to just be the cursor by the rest of it, you see we get 1, 2, 3, and so forth. So just by adjusting sort of by what we're going by, we can step through lists in different ways, and this will work for whatever we give it.
Yep.
So it's a bit, it's going to walk its way through.
Yeah, like a sort of.
No matter what, even symbols. We can have multiple clauses, so quite easily. So they're, X and Y that are getting added together.
Yep.
And then here's our loop within a loop that's gonna explode and then loop through that yet again. And
so you can set up more complex looping systems like this.
I think it's possible to do these within OpenMusic, like loops within loops, but
I've done loops within loops, but the problem is always that is this debugging limitation of the loop function.
Yeah.
And I think here, at least you can more clearly also build your code. So you probably will have a better idea what's going on, I think.
That's it. And especially because you can just take these loops and, I could plug it into my my Emacs and Slime and just and use the actual the steel bank debugger and stuff to tell me what I'm doing wrong. Here, here's I and J, so obviously multiple things, and this is gonna list. So A and B. We can actually destructure lists and put them into groups. So here we go, A, B, B, C, C, D. So if you're wanting to compare notes to the previous note, you can see how that can be quite useful.
Yeah, exactly. I was thinking the same.
And we could have a while something while x equal ij. The moment you find two similar notes,
then it stops.
We can stop.
Yeah.
Or replace, or if you stick in an if statement, if this is going to be this, then do something else. Our collect is
and have you used this in patches that you've written for concrete musical projects?
I think there was one. Did I use it for when I was messing about with first species counterpoint? I think I checking for parallel.
Yeah, exactly.
I compared the two. The moment I had two parallel fifths, I would then forbid them and replace it with something else. I think I even just stuck it. There's our if, and I would just. That's not very clear, but I just built in a bit of. So that was me just messing about with Fox's first species counterpoint. And by using this loop, I could collect the list and compare them, and then that was.
Can you share the counterpoint patch?
I think I have. I think
already in one of the previous ones.
Yeah, that would be in.
Probably.
God, I've even forgotten what I just looked up there. Session 3.
Okay.
Session 3. All those patches are there. Most of the patches that I share have a little Lisp function hidden somewhere.
That's good.
Yeah, and I actually got this page. These are 2 pages from a book, which go into these are 2 pages, and it's they call it the periodic table of loops, which is quite good. And it's the 4. There's so much more that you can do. Some
apparently
less,
yes.
cross,
Wow.
on, by, and else. There's so much stuff that you can. I just never even bothered with. I kind of shown the ones that I use the most.
Wow, that's.
I'll share this in the file, but and it gives you like a little example. I know it's not it's a bit blurry, but you can make
you can read.
And you've got the
which is the title of the book? Which is the title of the book?
This is Land of Lisp.
Yeah.
So this is one of in their chapter on loop. They've got this table, and it's really. I just thought this was so handy for. You can see how this stuff can be stuck quite easily into an Lisp function.
Like great! I see they have it in Kindle format.
It's a fantastic book. That's what I really learned a lot of from. And he talks about setting it up and all that fun stuff. I think that's all the stuff I've got for loops. I mean, it's certainly these are probably the most common that I use. I'll share this patch that I've called Looping World. To sort of show that. So you can click on you can edit those loops and tweak them to do whatever you want to do? Or
well, I have the feeling myself that the loop itself usually is pretty basic, or that it's just you have to feed it some information and then give it a stopping moment or something. That within the tools that OpenMusic itself provides, there is, like you say, it's fairly limited to basic looping.
Yeah, I mean,
usually collecting stuff. In my case,
I mean, you can see there's so much you can do with loops, and they are pretty powerful. They're the most they're kind of famous for being very unlisp like in their syntax. Like you can sort of see, even compared to the if I share my screen again, well, this didn't run, but this was the this would be the recursive function, and if we, this would be very lispy. Here's a lots of parentheses, whereas our loop function is very unlisp-like in its construction. It's very,
it has this kind of JavaScript like.
I mean, I've put in these to kind of I like to put in the colons to make sort of keywords.
You don't have to really
actually
do it.
No, these run fine without. It's for me when I'm writing, I just like to go. It makes the code much more readable for me when I'm writing, because sometimes if you got if it all kind of looks the same in X by Curter do print some whatever, it can get very it can start to look just a bit weird. So that's why if you make it this really doesn't do anything other than sort of tell it says keywords, so it makes it a little bit easier to read. But that's kind of what I do, but it's not necessary.
No. What I was going to say, I was just wondering, like, if you go to the existing libraries, for example, do they use a lot of looping?
What do you mean? In OM?
Yeah. I've always had the feeling that it's often really at the point that you start to construct musical wholes, musical. Let's go through the code. For example, of
I'm not sure if they use loops, but I've certainly seen a lot of I think it's mostly kind of writing functions and then a lot of map carring these functions together. And
I'm just gonna quickly go, for example, through the OM Tristan library. A little bit, but as I can see, like not hugely. No huge loops within loops. I must say, for me, they have always come into the point that you have generated or you generate something, and then you want it X amount of times on this starting point. I've used a lot of listloop. Let's say
I mean that's the most common one, I think. But I think that's with a lot of people, and I think especially with this video, I just wanted to kind of tap into kind of the
Yeah.
darker side of loops, that you can
Yeah.
provide it with much more these different arguments. And
I wonder, for example, musically, like how would you use the summing loop?
Yeah,
Like,
I mean,
where
there's so
does that
much.
even musically come into being?
Well, I mean, if you're, it doesn't.
Summation is not something which is kind of naturally part of musical structures, or maybe it could be. Maybe for time. Maybe for time
Yeah,
it could
I mean,
be.
it's not just pitch structure; it's
Yeah.
rhythm. And
Rhythms, it could be useful indeed.
yeah, I mean, you could
So the
what did
counting,
you
like counting bars or counting
counting
pulses.
duration? Yeah, just
Yeah.
how long is this line?
Yeah,
It's gonna
exactly.
last, and then
Yeah.
there's lots of information you can derive.
But then again, I think of like also I see a big relationship between the recursive thinking and the looping. Even
They're
though
similar.
maybe within the looping you don't necessarily use a recursive function, but at least that, like for example, the thing that we just mentioned, like how long is this? Like generate rhythmic material until
Yeah.
a certain amount of time is met. That would require you to write a recursive function generating this content. And then I guess in parallel, a sort of looping function where it always takes the new amount of generated material, compares with it, like I say, I want 15 seconds or something, and then stopping the recursion whenever this point is met.
That's one of the things that I kind of like, because I know someone wrote about wanting to cover kind of recursion, but for me, it's slightly difficult because recursion is very often the answer to a problem that you're having. So you need to kind of, to sort of say to someone, teach me about, or just tell me, let's cover recursion. You're like, well, I mean, we can sort of cover the theory, but it's not very helpful very often, because you need to be applying it to something that's happening. There's quite a good, because recursion is basically a function calling itself, until a condition is met. And that's what you need to know about recursion. But it's then how, the magic comes from the application of this, this superpower that's that these functions can have, and the sort of the problem solving aspects that are unlocked by being able to do this. But it's a very, this is recursions. There's some good YouTube videos. Computer File, I think, have a video. They do it in Python. I can't remember. He's an Austrian academic, and
I think I know the channel.
The Pillars of Hanoi or something, and it uses Python script to write a recursive statement to solve that problem. And that's a really good video, and he goes into a lot of detail about why. And obviously, he's using Python, but you can easily see how you would write that in Lisp as well. But it's
but as far as I understand, it does require code writing somehow.
Well, that's, I mean, the function. He writes a little Python function that's recursive, and that's it. It's a function that's recursive. It's a function that calls itself. And Lisp, because that would obviously then require hooking up and function
it's
back
where
onto itself.
Global patches come into play.
Exactly. That's something I haven't touched on. That's I've never really. I know you can sort of do that with macros. I didn't think about doing that with anything with patches.
But it seems somehow more organic to try to write it in code, because I can imagine after a while having this kind of huge folder of global patches that maybe you only use for projects, and then I think it it makes more sense to just write it out in code within the patch. That's
yeah. I mean, you can. That's the thing about Lisp and as opposed to an extent OpenMusic. You can do the same thing 12 different ways.
Yeah,
and it's I've personally find not that I write lots of recursive stuff for for loops, but if I've needed to, it's a couple of lines of code in a lambda function kind of does it. Does what I needed to do very often, or not even lambda, not just a function in a library that you can just kind of call upon. So maybe recursion is something we could look at. We can add that to the Google Docs whenever.
Yeah, exactly. I was thinking that as well, because I'm first going to read a little bit this chapter.
That chapter is fantastic. It's very easy to read.
You'll probably I can already figure out some stuff myself.
The language of that chapter is just really like it's a story. The Martin and the Dragon, and it's quite it's really enjoyable. It's very nerdy, but it's fun.
I think it's I don't know if it's a personal taste, but the method of recursive thinking touches a lot of like more mathematical phenomena like fractal thinking and all these kind of things, which I think I often recognize with composers from the last 50 years that I like setting up ligeti like structures or stuff. There often in the end I notice that some recursive operation is necessary. And I've had trouble implementing it in OpenMusic basically from day one, from the moment that I figured out that it would be necessary to do that.
Well, I would read that chapter and then just try and code some of the stuff. You could even just do it in the OpenMusic REPL, the OM listener. You could just write. I did. I just copied and pasted that function in, and it's very straightforward. I've got to run. I've actually got to go to do a thing.
Yeah, me too.
But I think we've covered quite a bit here.
Yeah. And surely I think it's a subject, this idea of looping, which for next sessions we might think of new stuff.
Definitely. I'll set up that Google Doc and
I must say I have rarely patches where I don't use looping. It's more like
absolutely.
It's kind of a fundamental part of creating a structure.
Absolutely.
So I think I also need to think. Let's see quickly. Oh no, this is without. Everything having to do with fractal thinking, with like I was playing with some construction of scales, for example. Which were, for example, a major scale would be the mathematical fractions which make up the tempered major scale would be applied to its constituents actually. So you get a whole microtonal set of micro pitches, and there obviously, I think looping is a very important part of creating those. But I think the one big challenge in looping is being able to follow. This is maybe something for a next session, which would be interesting, and where I would maybe also do some research myself. Is you create a loop, but I think in any loop you create, it's interesting to be able to follow the process as closely as possible.
Well, putting in the print functions and things to kind of see what's happening.
And to figure out how to kind of, for example, partially collect or intermediately collect stuff. And then see like, okay, I can use this, or it's first doing this, doing this. And this is something where I think maybe we haven't touched everything ready.
It's such a huge. I mean, there's so much. I think it's. I tried to just cover the things that I've used most.
Yeah.
But it's.
Exactly.
I definitely like our macros. We can do looping 2.0 video.
Yeah, and I mean, little by little, new libraries are also popping up.
Yeah.
I've been looking into the library by Fabio Sanctis de Benedictis, Italian guy.
Yeah.
And also the one from Rubensferen Gjertsen, which are actually quite interesting because they are very multi-purpose, general. Like they don't do specific things, but they do a lot of little things that are very useful, not to have to code yourself always.
I know. I really do need to look into libraries and stuff, but I've got to run now.
Yeah.
But
So
thanks very much for joining me.
Yeah, and well, I need to say another thing.
Oh, go ahead.
When you finish recording.
Oh yeah. I tell you what, I'm gonna stop the recording there. So thanks everyone for watching.
See you soon, guys.